In number 7, we're dealing with special right triangles, and the one that you see in the diagram is a 45, 45, 90 degree triangle. I could add this up here if it helps me. That means it's an isosceles triangle, which means the legs are also going to be the same length, and that'll allow me to solve for those two missing parts. Okay, the first part is really easy, and I've kind of marked it as such. We know one side, and you know it's got to be the same as the other side because those are the legs of the isosceles triangle. So it's pretty easy for us, without doing any work, to just say that B must have a value of 3 times the square root of 2 because it's got to be the same as the other side. The trickier part of this is solving for A. And in this special right triangle, we kind of have to remember this equation that allows us to compare sides of that special right triangle. This hypotenuse is always going to be the same distance as the leg times the square root of 2. That equation only works, and that comparison of those two sides of the triangle only works in a 45, 45, 90 triangle. Okay, that's what we've got here, and so we can plug values in. The hypotenuse is a value of A. The leg that we know of, it doesn't matter if you're looking at this one over here or this one over here, they're the same distance, the same length of 3 times the square root of 2, and we're going to multiply that all by the square root of 2. Okay, so we've got A on this side, 3 times square root of 2 times square root of 2, those two things together, square root of 2 times the square root of 2, equals 2. Bring down your 3. A must be 3 times 2, which is a value of 6. This entire distance of the hypotenuse here is 6. I know that that's true because I got it from this formula, which only works in a 45, 45, 90 degree triangle.